Hi, this is David Allen Greer. This video is a short version of a talk that I gave at the International Conference on Consumer Electronics. It's part of the Consumer Electronics show in Las Vegas. In this talk, I was asked to look at 5 different technologies, put them into context, and explain how they were advancing together. Those technologies are the smart grid, second, the Web of Things or the Internet of Things, third, green information and communications technology, fourth, autonomous vehicles, and fifth and last, life sciences technologies.
I started this talk with what I called the cautionary tale of 3D printing, as a way to explain that we need to think deeply about how these technologies fit into society in order to understand them. I had been receiving a lot of press inquiries this year on 3D printing. They came from enthusiastic and energetic reporters who wanted to believe that 3D printing was the technology to solve all ills, that it was an answer to the lack of energy, to the challenges we faced in manufacturing. Indeed, one reporter wanted me to say that 3D printing would be able to print food and thereby feed desperately poor parts of the world. Time and again, I had to tell these reporters that they were missing the point of the technology, and that they were participating in what I call the pendulum of poorly grounded emotional response. The Gartner organization calls this curve something slightly different, but apparently they have not read Freud or Jung. Any new technology seems to bring with it a certain kind of emotional response that climbs rapidly to a peak of unreasonable enthusiasm, and when it fails to meet expectations, plummets into a trough of unexpected, for some people, disillusionment. Only then does it climb onto a path of conventional acceptance before it finally curves downward in the gentle arc of lost fashionability. I would go on to explain that 3D printing was an example of a technology known as numerically controlled machine tools. This technology has existed since the 1950s. We have a lot of experience with it, and we know that it flourishes in a certain kind of ecosystem, an ecosystem that requires a certain financial qualification, a certain kind of data or intellectual material, a certain managerial framework that allows it to be used effectively, and finally, it has to fit into an organization in the right way. As an example of a small numerically controlled machine tool that's fit into an unusual ecosystem, you can look at the crown milling machine. This is a device that dentists now use to create crowns for teeth. It's something that they can have in their dentist office and that they don't need to send to a lab or to some other company to make crowns for their patients. It fits very neatly into that ecosystem. It requires a relatively small-scale capitalization that meets the capital that can be raised by a single dentist in a private practice. The material they're working with, the shape of the mouth and the tooth and the place that needs to be fixed, is easily digitizable, and there's no intellectual property problem. It radically reduces the costs and time of getting caps and crowns on their patients, and so it fits managerially into their environment. And finally, it is being handled by a workforce that is already quite skilled in working with teeth and other tools, and so they very naturally can engage this new technology. To understand how this environment works a little better, we can look at a failed numerically controlled machine tool, or one that is really less of a success. That tool is the numerically controlled sewing machine, which has been quite successful in industry, but it was also promoted as something for the home, something that would allow individuals to recreate the newest fashion in their home by purchasing materials and downloading programs to help create new clothes. In fact, it's been a very limited success at the home. First off, there are minimal savings, and also fewer people are sewing at home. However, more importantly, it replaced one skill, the skill of being a tailor, of working with cloth with your hands, with the skill of running a numerically controlled machine tool. And the general audience of people who do sewing are often very proud of their skills and have no interest in becoming a skilled operator of a machine tool. To summarize that ecosystem, there are 4 elements that we're going to consider. First, A new technology has to be in a place where the capitalization, the cost, makes sense given the scale of business. Second, it has to involve knowledge that is either easily mechanizable or appropriately mechanizable. Next, you have to fit into the skill sets of your workers or modify those skill sets in appropriate ways. And finally, and this is perhaps the most important, it has to have a straightforward way for engaging a larger organization.
And here we get to the fundamental premise of this talk, that these 5 technologies are changing the ways that we work together. They're changing the ways that we produce goods and services, the ways that we collaborate, the ways that we make decisions. And it is changing these ways in 3 fundamental directions: economically, socially, and psychologically.
Let's first consider how the smart grid fits into this ecosystem of new technology. On the capitalization side, it's an easy fit. The electrical industry is a highly capitalized field, and it can absorb many new complicated and expensive technology. The same is true with the knowledge and data field. It is heavily engineered and can make good use of digital and other forms of new technology. On skills, it's also a good fit, as it has a large technical workforce with strong skills that can be adapted for the smart grid. So the question becomes, how is it altering the organization in which it works? And in this case, the organization includes the customers of the electrical distribution system. It's using economic engagement, and in particular market mechanisms, to change the way people use electricity, when they use their various appliances and utilities, when they might charge their car, when they would plan factory production. This industry has a long history of using economic tools to shape its customer base and its organization as a whole. Samuel Insull, one of the very early leaders of utilities, was an important advocate for economic and market mechanisms. I should add this idea of using market mechanisms to change any kind of group, a customer group, a group of citizens, the structure of an organization, is also the pattern for other technological initiatives, such as smart cities and similar kinds of issues that involve sharing resources. When we look at the transportation initiatives, we're looking first and foremost, in this case, at the self-driving car, autonomous vehicles. Again, if we look at the infrastructure, we see that the capitalization fit is good. It's a highly capitalized industry that produces an expensive product. Hence, it can absorb a new technology easily. If we look at the kind of knowledge and data available in this industry, we see that there's an opportunity and that indeed they have collected a great deal of useful information over the last 30 or so years. If we look at the skills replacement in the industry itself, we can see that that's going to be a tougher problem. But we've already been through part of that kind of change already. In the United States, the auto industry changed a very large fraction of its workforce in the late 70s and early 80s, when it converted from mechanical to electronic engine control. The real challenge is going to be in the customer base, and again, it's going to be an organizational change. In the case of autonomous transportation systems, it's going to be more of a social change than an economic change. In particular, it's going to change the roles that people have in relation to transportation. This technology is going to change the social factors of position, the relation that people have to each other, status, the amount of influence they have over each other, and finally, function, what an individual person does. Obviously, it's going to be the function of the driver that changes. And with that, the other 2 factors will be changed as well. We're already seeing some evidence that there is a shift going on in the function of the driver, because we now have a generation of individuals who are used to using car-sharing organizations rather than owning their own vehicle. These people don't drive as much, they don't have as much experience as drivers, and we're seeing a little evidence that they're not as good drivers, that their skills are not as sharp, and hence they may be more open to changing their function. The life sciences initiatives within the IEEE and the electrical and electronic engineering community actually have multiple initiatives. Things include personal sensors, electronic medical records, and of course telemedicine, where healthcare is delivered at a distance. If we look at the new technologies ecosystem, we see that again it's a highly capitalized industry that is in many ways independent of certain market forces, that there's a lot of knowledge and data that can be adapted to the new technology, though some of it may be difficult to convert. And finally, it's a very skilled industry that has a lot of people who can transfer their skills to the new technology. The organizational changes for medicine may be substantial, as they're going to require the customer base, the organization in this case, to change the way they think about their health and how they maintain that health. We have gone through such changes several times before. In the United States, the Pure Food and Drug Act of 1906 and the Flexner Report of 1910 radically changed our ideas about medical knowledge and health and who had the right to use that knowledge. It brought on, for example, the right of self-medication and the idea that there was a centralized medical knowledge focused on hospitals, teaching facilities, and doctors' offices. Ultimately, new life sciences technology may again change our ideas and norms about these things. The other technologies are much more supportive, and how they fit into the new technology ecosystem will depend heavily upon the application. This is certainly true of the web or Internet of Things. It's likely to have applications in things such as smart transportation and the various forms of smart cities and other ways of bringing technology to urban infrastructure. The green information and communication technology initiatives will be a much easier fit into the ecosystem because it will eventually be all of ICT, all of information and communications technology. We simply can't sustain the current rate of growth of power for these technologies, and soon we will have to pull them back. We will also have to come to grips with the issue of solid waste disposal of this technology. There is great opportunity in this problem, for while we have used ICT technologies to understand supply chain, we have not done the same thing with disposal chain, and we now need to look at our own disposal of our own technology, which is creating massive landfills in Nigeria, in Indonesia, in southern China, and in India. When we look overall at these technological initiatives, we see that we need to understand four basic elements to understand how they work together and where they're going. How they work into the capitalization of their application, the kind of knowledge base they require and data that is needed for input to them, the skill set of the workers that will be using them, and finally, how they alter the organization, which can include workers, customers, and other individuals who are part of the production process. We should note that all of these technologies are based on software or have large software components. And software is a powerful force in technology. It has restructured electronics, and it really has little direct connection to electronics because it's based on the ideas of production engineering. And these ideas directly address the issue of organization and structure. Production engineering fundamentally separates leadership or knowledge from work. This kind of separation has done some good things. It allows people to concentrate on the ideas and skills which they wish to develop and rely on others to do things that they do not. However, we're still working to understand what kind of global society it creates and what kind of global society will be sustainable under these kinds of technologies.
The only thing that we can say at the end is that we live in innovative times and that we seem to be seeing these 5 technologies fundamentally reordering society. This is David Allen Greer. Take care.